In this video, we're going to be discussing our special angles. So we have two triangles here, which we refer to as special triangles. And we are going to look at the first triangle and how it can be used to work out some of our special angles. So the first triangle that we have here is clearly an isosceles right-angled triangle. We know it's isosceles because we can see that the two shorter sides each measure 1 unit. Now, by virtue of the fact that it is an isosceles triangle, we know that these base angles, angles A and B, they must be equal to each other. Now, since this is already a 90-degree angle, then it means that the remaining two angles, A and B, must be equal to, their sum must be equal to 90 degrees, right? And if the sum is 90 degrees, then it means that each of the angles must be 45 degrees. So we can go ahead and put in the size of the angles. Angles A and B each measure 45 degrees. Now, using Pythagoras' theorem, we can also work out the length of the third side, which is really our hypotenuse. So remember, the side that is opposite to the right angle is always the hypotenuse. So according to Pythagoras' theorem, a squared plus b squared is equal to c squared, where c is the hypotenuse and a and b are the two short sides, the lengths of the two short sides. So if we know that the two short sides each measure 1 unit, then it means that the hypotenuse would be 1 squared plus 2 squared equals c squared. So if I work that out, 1 squared is 1, so we would have 1 plus 1 equals c squared. So it means that c squared is equal to 2. So it means that c, which is the length of the hypotenuse, is given by the square root of 2. Now, because we want to keep our answer exact, we're going to keep our answer as square root of 2. We won't work out what square root of 2 is. So the length of the third side, I'm going to call it square root of 2. So now that we have the lengths of all three sides and we know all three angles, it means that we can go ahead and work out some of our trig ratios. So I can use any of these 45-degree angles to work out the trig ratios for 45 degrees. Now remember our acronym SOHCAHTOA. So sine relates the opposite and the hypotenuse. So if I'm using, let's say, angle A as my reference angle, then it means that sine of 45 degrees would be equal to the opposite side, which would be this side down here, divided by the hypotenuse, which is root 2. So sine 45 degrees would be 1 over the square root of 2. Now to find cosine or cos of 45 degrees, again, we look for the adjacent side and the hypotenuse. So if I'm using angle A once again as my reference, then this side over here would be adjacent to that angle. And so cos 45 is again 1 over the hypotenuse, which is root 2. Now, if I'm looking for tan of 45 degrees, tan relates the opposite and the adjacent side. So again, using angle A as my reference, the opposite side measures 1 unit and the adjacent side also measures 1 unit. So it means that tan 45 degrees is just 1 over 1, which simplifies to just 1. So that is how we would derive the special angles for 45 degrees. So we go to the second triangle. Now this second triangle, as we can see, it's an equilateral triangle because all three sides have the same measure of 2 units, which means that all the angles as well have the same measure. So if the angles in a triangle sum to 180 degrees, then it means that each of these angles must measure 60 degrees. So we would have to divide 180 by 3. So each angle in this triangle measures 60 degrees. Now let us consider what would happen if we were to split this triangle, bisect it, cut it into two equal halves. So if I split this triangle right down the middle, then I see that I would have formed two right angled triangles, right? So I'm just going to consider the right angled triangle on the right. So if I have split this triangle into two parts, then it means that firstly, the base of the triangle CB, each half would now measure 1 unit, right? Now for the angle that we bisected, the one up here, each of these angles, since we cut it into two parts, each of these angles up here would each measure 30 units, 30 degrees rather. So now this triangle has angles, each of the right angle triangles has angles 30 degrees, 60 degrees, and 90 degrees. And that is exactly how we name this triangle. We call it the 30, 60, 90 triangle. And the one over here on the left, we would have referred to it as the 45, 45, 90 triangle. So using the 30, 60, 90 triangle, we can work out the trig ratios for the 30 degrees and the 60 degree angles. So I'm going to start with the 30 degrees. So it means that we would be evaluating angle A in this right angle triangle over here. Now, before we can work out those ratios, however, we would still need to find the size of this line right here that we used to bisect the triangle. So again, we can do that using Pythagoras' theorem, which again states that a squared plus b squared is equal to c squared. In this case, we don't know the length of one of the shorter sides. So I'm going to refer to that side as side A. So it would mean that a squared plus the length of this side, 1 squared, is equal to the square of the hypotenuse, which was 2. So that's 2 squared. So I would have that a squared plus 1 is equal to 4. So it means that a squared would be equal to 4 minus 1, which is 3. So a, again, would be the square root of 3. So I can fill in the length of this side right here as the square root of 3. So now that I know all three sides, all three angles in the right angle triangle, I can go ahead and work out the trig ratios. So I'm going to start with sine 30 degrees. So sine 30 is the opposite side. So the side opposite 30 is 1 unit over the hypotenuse, which is 2 units. So it means that sine 30 is 1 over 2. Now cosine 30, again, cosine links the adjacent and the hypotenuse. So the adjacent side to that 30 degree angle measures root 3, and the hypotenuse is 2 units. So it means that cos 30 degrees is equal to the square root of 3 over 2. And tan 30 degrees, which relates the opposite and the hypotenuse, the side opposite the 30 degree angle is again 1 unit, and the side adjacent is root 3. So it means that tan 30 is just 1 over the square root of 3. Similarly, we can work out the 60 degree angles. So sine of 60 degrees would be equal to the opposite side. So the side opposite the 60 degree angle is root 3. And the hypotenuse is 2. So it means that sine 60, is just root 3 over 2. Now for cos 60 degrees, cos is the adjacent side. So the side adjacent to cos is 1, and the hypotenuse is 2. So it means that cos 60 degrees is equal to 1 over 2. And tan of 60 degrees, again, is the opposite over the adjacent. So the opposite side is root 3, the adjacent side is 1. So it means that tan 60 is the square root of 3 over 1. and anything over 1 can just be written as itself. So this is just equal to the square root of 3. So I hope this video was helpful and you can use it to derive the special angles without having to memorize them.